Okay, in this video, we are taking a look at this thing called coordinate geometry, which is, to put it plainly, all the geometry we've been doing, just now on a coordinate plane. So now I actually have a reason for using graph paper in these videos. The main thing we want to take a look at today is how do I use the coordinate plane to figure out how far apart 2 points are. In the past, since there was no coordinate plane, there was no point of reference like we have the origin now. Um, the only way to get distance was if I told you what it was, or something that's related. For example, using a right triangle and then using Pythagorean theorem to figure it out. But now we don't actually know that, and I just know these 2 points. So let's take a look at an example. So let's say we want to figure out how far apart the points -2, 3, and 5, -1 are. So really, how far or how long is this red line? Now, since on the coordinate plane, I only know that each of these little boxes is 1 unit, or maybe 2 units depending on how I scale my axes. I know that I can't actually just measure this out because there's no way I could just line it up along one of either the x-axis or the y-axis because again it's diagonal. But what I do know is, well, let's take a look at all the straight line distances that I do know. And by that I mean the ones that are parallel to the x-axis or parallel to the y-axis. So the one parallel to the x-axis, well, I could think of it as this purple line right here. Since I know that each of those boxes is distance 1, I know that this purple line is 1, 2, 3, 4, 5, 6, 7 units long. So to get from the -2, 3 point to the 5, -1 point, it's as if I went 7 to the right, and then how far down? Well, 1, 2, 3, 4 down. Now, what do I have? Well, if you think about the fact that this is on a coordinate plane, the coordinate plane consists of a bunch of parallel and perpendicular lines. And so you actually have a right triangle here. And so if I actually want to find how far apart these points are, I'm really just using the Pythagorean theorem. In this case, that's going to look like, I'll call this distance d. D is equal to the square root of 7 squared plus 4 squared. And that'll just be the square root of, let's see, 49 plus 16, which is the square root of 65. Okay, so if I have the 2 points, then I could always draw a right triangle to connect them. And essentially those 2 points would be the endpoints of the hypotenuse of that right triangle. But what if my points are really far apart and I couldn't see, or I didn't want to count out how far to the left and then how far down I have to go to get from one point to the other? Totally makes sense. So there has to be an algebraic way to do this relatively quickly. And there is. So let's clean this up and let's take a look at this. So if I just take a look at their horizontal distance away, I'm going to draw in right here vertical lines between those points. And those are just marking off where their x coordinates are. So right here, on this vertical line right here, this is the vertical line x equals -2, which it represents where, horizontally, this -2, 3 point is. And this vertical line on the right side is x equals 5. If you remember way, way back when we were talking about the distance postulate on just a line, the way to figure out how far away 2 points are, it was actually the absolute value of their difference. And so the actual length of this would be equal to 5 minus -2, but then you take the absolute value of that. And that would be the absolute value of -7, which is just 7. Now, it actually doesn't matter which way you do the subtraction because you're taking the absolute value. And so if instead I wanted to do the absolute value of -2 minus 5, oh sorry, the first one would just be the absolute value of +7, which should be 7. But now I have the absolute value of -7, which again is just 7. Likewise, if we look at the y coordinates at this green line right here, this is the line y equals 3, and down here is the line y equals -1. And so the distance between them would be the absolute value of their difference. 3 minus -1, the absolute value of that would be 4. This gives you the length of each leg of this right triangle. And so the length of the hypotenuse would simply be the square root of, again, each of the legs. So square root of a squared plus b squared, where one of them is a and one of them is b. Now you might notice that to take the square root of something, the number inside it has to be positive. But because you are squaring whatever a and b are, it actually doesn't matter if it's positive or negative. So even if you forgot the absolute values on, say, this one, and let's say your length you decided was -7, it actually wouldn't matter because once you throw it into your formula here, it's going to be squared. So if you had -7 and -4 for whatever reason, by accident, your distance is still going to be -7 squared plus -4 squared, which is going to turn them positive anyway. So this gets us to our actual distance formula, where let's pretend I have 2 points right here. I'm just going to call this point x1, comma y1, and I call this one down here, perhaps, x2, comma y2. If you want this distance right here, that distance is equal to, well, the difference in their x values will give you one leg, so x1 minus x2 squared, plus the length of the other leg will be the difference in their y values, y1 minus y2 squared. And that's how you can find the distance between any 2 points on the coordinate plane.